Now, in the interaction of radiation with matter, for example, if this radiation is going like this and there is, let us say, certain matter is there, and if this radiation interacts with this matter, and if I see that some particles are broken down like this. Now, we have just seen an example. If we hammer the wall, particles gets broken down, right? Now, instead of hammer, we are using radiation over here, and what we can see that these particles are broken down. That means in this case, this radiation is behaving as a matter, right? So, let me call that matter as photon. Okay. Now, when that radiation behaves as matter, I am calling that matter as photon. Okay. Now, we know that how do the radiation get released. We know the structure of atom, like at the center there is nucleus, and then there are orbits where electrons are revolving. Okay. And we know that when the electron jumps from higher energy level to lower energy level, it releases some radiation. It releases the radiation. Just imagine that the electron is jumping from higher energy level to the lower energy level. It is releasing the radiation like energy get enclosed in certain type of packet. Can you see this structure? Let me call it as packet, and we know that if the radiation is released, it has certain amount of energy. That packet is enclosing energy into it. Again, we call that packet as photon. Okay, so the radiation which shows the properties of matter, I call that radiation as photon, and I am defining it in two ways. First way to define the photon is in the interaction of radiation and matter. Radiation behaves as if it is a matter, so I call it as photon, and in the second part I am defining photon as a packet of energy. Now, okay, so if photon is a packet and it has an energy, let me tell you what amount of energy that each packet possesses. First of all, let me give you a very simple example. There you can imagine how the photon looks like. Consider the balloon filled with colored water in it. This is the balloon and it is colored water. Okay, I am throwing that balloon towards the wall. This is the wall, and I am throwing that balloon like this. Now, what will happen when that balloon will strikes the wall? That color will spread over the wall like this. Spreading will be there. Now, you can see here two things. First thing is this balloon is traveling towards the wall. That means it has momentum. Right. So, we can say that it is in matter form right now, but when it strikes the wall, it gets spread. That means colored water gets spread on the wall. So, here I can see the radiation or the wave nature, right. So, the dual nature can be shown, right. So, here this dual nature is trying to explain you that photon is matter as well as a radiation form. Anyways, when I am saying that the colored water possesses an energy, so just compare this colored water with the energy and this energy is enclosed by that balloon, compare that balloon with the photon. So, here there is a photon filled with a certain amount of energy. Now, let me tell you what is the value of that energy. So, the value of that energy which is filled is h nu. Now, what is h? H is Planck's constant over here. Its value is 6.63 into 10 to the power minus 34 joules second. What is nu? Nu is frequency of radiation, and we know that frequency is given by c by lambda, like this. So, you can see this formula can be updated like this, h c by lambda.